I was working in Adelaide in Australia, and someone walked through the door who turned out to be someone called Bruce Candy, who's an inventor, and one of the many things he invents is amplifiers. So he had a design for an amplifier, and he wanted to understand the maths for it. Now, at that point I knew nothing about amplifiers. These things are called Class D amplifiers. So the way it works is it generates lots of pulses at high frequency, and what it does is it varies how wide those pulses are depending on the audio signal. And so it's quite hard to build because you need a really high frequency set of pulses at the output, and that kind of pushes where electronic components are. So he's a physicist, physics graduate from Adelaide, and he invented this amplifier, and it's a good amplifier. Sells for about £20,000, so it's very high-end audio. So I learnt some of the maths that you need to describe the amplifier. It's all just physics, right? It's all just electronics, and electronics you can write in terms of differential equations. The other really cool thing about working on that project, given that I started off knowing nothing about amplifiers, is that just by doing the maths, but not really knowing anything about amplifiers, I managed to invent a new design of amplifiers. So with a proper amplifier you could try tweaking things, you could try changing one of the resistors or changing the design, but you've got to know how you're going to change it to do that. With the maths you can say, what if I put in a different voltage there? What would happen? And you don't have to know what that voltage is, you don't even know where you're going to put it, you just put it into the mathematics, and then you try to tune that to get rid of some of the distortion, to try to make the amplifier a bit better. And turns out I found a new way of doing that. Now, it was never commercialised. I don't have any amplifiers that I sell that cost £20,000 each, but I managed to convince Bruce to build the thing that I'd invented from the maths. So the first time he did it, he hadn't been quite careful enough about how he built it, but the second time he built it, it worked. And it worked just as I predicted. I found a design for a Class D amplifier that had been published in some electronics magazine a couple of decades ago, and I built that one. And it works. And the reason I built it is that I sort of knew from the maths that this Class D amplifier thing worked. But it works in a strange way. So there's another bit of my brain that doesn't really believe that it works. And that bit was nagging away at me, so I had to build something. I'm not trying to build an amplifier that you'd actually use for anything other than proving to yourself that this design really works, because it's an odd kind of amplifier. It doesn't do what you'd expect. It has all these pulses that it sends to the loudspeaker, and that doesn't, even though mathematically I know that's right because I've done the maths of it and it works, there's another part of my brain that says that, hold on a minute, that can't be right. There are lots of long wires in the amplifier that I built, which means, coupled to the fact that it involves high frequency generation of pulses, that it works a bit like a radio transmitter. So it's an instant, it's almost like a jamming device. I can interfere with any. The reason we're not showing the amplifier on the video is that I've got a nasty suspicion that if I switch it on, it'll stop your camera working. Those pulses really are the audio signal in disguise. And the reason you want to have pulses in the output is that the pulses are either always on or always off. And if you send a signal to a loudspeaker that's always either on or off, then you don't waste any energy in the amplifier. So you don't lose any energy to heat. So lots of stereo systems, if you run your stereo system, then it will get warm or even hot because you're wasting energy. And these Class D amplifiers are really efficient. They don't waste any energy. And that's for the £20,000 ones that you plug into the mains. It's not really important whether you are kind of energy efficient or not. But they also appear in mobile phones and iPhones and iPads and all kinds of laptops and tablet PCs. And there, everybody wants the battery to last forever. We want those kind of things to do more and more jobs, and we want the battery to last. We don't want to be recharging the thing forever. So one of the things that you can do to help make your battery last is to have a good amplifier, and then have a Class D amplifier.